Good afternoon, everyone. My name is Harish, and I'll be with you in this lesson talking about an introduction to drilling engineering. Well, before we get started, I just wanted to let you know that every week we make a lesson just like this one talking about different branches of petroleum engineering, such as reservoir engineering, production engineering, well logging, and drilling engineering. And these lessons are being prepared by 4 graduated students from Petroleum Engineering Department, including Mr. Safin, Mr. Ahmed, Mr. Aza, and including me. And guess what? Today is my turn, and I'll be with you talking about drilling engineering. Alright, so let's get started. In this lesson, we'll first give an introduction to what the drilling engineering is in general, and then we'll talk about the responsibilities of drilling engineers. Then we'll talk about the types of drilling wells. We've got 4 major types of drilling wells. Then we'll talk about the drilling methods. We've got 2 methods in general, but one of them is no longer used, the cable tool drilling. This one is no longer used. It was very common in the past, but nowadays it's no longer used. The most common drilling method is the rotary drilling, and this is the whole reason why we will talk about the main components of the rotary drilling rig and their functions. Well, if we define the drilling engineering as an introduction, we'd say that it's the technology in which a hole is made into the earth, whether this hole is vertical or directional. Directional means the hole is horizontal or the hole has an angle. When the hole is angled means it's directional. Well, and these holes, whether it's vertical or directional, these holes are made into the earth by using a rig, a drilling rig. This is a drilling rig right here. All these components combined together and they're working together, they're creating a rig. And a rig is used for making holes into the ground. Well, why do we drill? Why do we drill the earth? Well, we drill in order to reach the underground hydrocarbons. Hydrocarbons are oil and gas. We want to reach them and extract them. Extract them means to produce them to the surface. Another reason why we drill is to inject fluids into the reservoir. This is quite the opposite of extraction. When you extract, you get the fluids from the reservoir to the surface. When you inject, you input the fluids from the surface into the reservoir, and this is a process called secondary recovery. It's done in order to increase the pressure of the reservoir. Another reason for drilling, it's to explore the reservoir, the exploration, like when we drill the exploration wells, and these wells are to confirm, to get more information about the reservoir. When we want to get more informations, to obtain more information about the reservoir, we explore it by drilling an exploration well. And another reason for drilling, is to stop production from a producing well in case of emergency, and for some other reasons. This one is really not needed to talk about as an introduction, but the idea here, I just wanted to tell you that drilling is not just for producing fluids from the reservoir. No, it's also for injection, it's for exploring, it's for stopping the production from a producing well in case of emergency, and for some other reasons. But for now, these are enough. Alright, now the responsibilities of drilling engineers in drilling operations. The main responsibility of drilling engineers is to facilitate the efficient penetration of the earth. Now, penetration is like drilling. To drill means to penetrate. They're the same thing. Now, how do they make the penetration to be efficient? This can be done by selecting an appropriate drill bit, an appropriate mud weight or type of mud, and they take many other operating parameters into consideration in order to create an efficient penetration. This is their responsibility. They're responsible for all these things. Alright, another responsibility is to facilitate the casing and cementing operations. These 2 operations are done in order to prevent any damage to the well or any harm to the environment. Like how can these damages and harms can be done? You see, this is the formation, and this is the wellbore. This is the formation all around the wellbore, and this formation contains fluids. So suppose we drill a section without casing it, without casing the section, then the fluid inside the formation may get into the wellbore and create problems. Sometimes these fluids that are getting into the wellbore may create a high pressure, and this pressure of this fluid may create a blowout. You know, a blowout when the well blows out, when the fluid comes out of the well to the surface, to the rig. And these blowouts may damage the entire rig, not only the wellbore. And these blowouts will damage and harm the environment and the personnel working in the rig. Alright, so let's talk about the types of drilling wells. Well, as we already talked about, we've got 4 major types of drilling wells. First one is the exploration well. It's also called wildcat well, the appraisal well, production well, also called development well, and the abandonment well. And we'll talk about each one of them in detail. And first, we'll talk about the exploration well, or the wildcat well. You know, this well is drilled during the initial stages of exploration to prove the survey results whether the reservoir rock contains any hydrocarbons or not. Well, if you can remember from the last lesson about exploration, we talked about the geologists, that the geologists conducted survey operations over an area in order to find where the reservoir is located under the ground. And they managed to find it by survey results, by like seismic survey. Well, they will be able to locate the reservoir under the ground, but they will not be sure whether this reservoir contains any hydrocarbons or not. In this case, the geologists will ask the drilling engineers to come and drill exploration wells in that area into the reservoir to prove the results. And then, after the exploration well is drilled, then the core samples will be taken from the well and the logging operations will be performed on the reservoir. Now the core samples are small portions taken from the reservoir to a reservoir laboratory in order to conduct experiments on this core, on these portions of the reservoir, and thus they will find out whether the reservoir contains hydrocarbons or not. And well logging is for the same thing, but usually the results from well logging are not relied on. Usually not relied on. Well, suppose that after the exploration well, after taking the core samples to an reservoir laboratory and the experiments are conducted on, and the results showed that this reservoir does contain some reservoir. Okay, it contains, the reservoir contains the hydrocarbons. Okay, the reservoir contains hydrocarbons, but how much? How much hydrocarbons does this reservoir contain? To answer this question, we'll have to drill another well called appraisal well. Not just one, maybe we're going to have to need to drill some more appraisal wells, maybe 10, maybe 5, depends on the results. We'll continue drilling, we'll continue to drill wells like appraisal wells, exploration wells, until we get enough data from the reservoir. Well, this well, the appraisal well, is drilled to determine the extent, the size of the reservoir, and the amount of the initial hydrocarbons in place. Now, so it's a given that this well, this type of the well, is for identifying how big the reservoir is, the volume of the reservoir, the size of the reservoir, and also to confirm how much hydrocarbons are in this reservoir. In place means in the reservoir. So, if after drilling this well, after taking the parameters like how big the reservoir is, how much hydrocarbons are in place, and then we'll calibrate these results, and then finally, if we find out that this reservoir contains enough hydrocarbons, we will proceed with production wells. We will drill it to extract hydrocarbons from it, but only when the reservoir is economically viable. Economically viable means that the reservoir contains enough hydrocarbons that if we drill it, our profit will be more than our cost. So economically viable means the cost will be less than the profit, and the profit will be more than the cost. Alright, so suppose that the reservoir contains enough hydrocarbons. The reservoir is economically viable. Then we will proceed with production well. We will drill production wells in the reservoir to extract the hydrocarbons to the surface. This is what the production well is for. See, this well is drilled in proved production field for the purpose of extracting hydrocarbons from the reservoir to the surface facilities. Now here I just wanted to point out that proved production field, it means an area or a field that all the necessary information are available about it. Like if a field is well known or all the information are available, then that field or that area is called a proved production field. Because guess, we will not drill any production well in an area that less information are available about it. So the production wells are only drilled in proved production field. Means only the fields that all the necessary information are available. We have provided or we have obtained all the necessary information about this field because we have conducted survey operations like seismic operations from the geologists, and we have drilled exploration wells, we have drilled appraisal wells. That's why the area that we have drilled a production well has become a proved production field. Alright, so let's talk about the abandonment well. Now, all the other three types of the drilling wells that I talked about can become abandonment well. How? Now let me tell you one by one. First, the exploration well. You see, the exploration wells are used to identify whether the reservoir contains any hydrocarbons or not. So suppose we have drilled an exploration well and the result showed that the reservoir does not contain any hydrocarbon. No hydrocarbon discovery is found. Then in this case, the well should be closed. The well should be isolated. And how to isolate it? We use the cement. We put the cement inside the well bore and we will close it. We will isolate it from the environment so that the environment will be safe. If we leave it open, then the well may damage the environment. Some other gases under the ground may come into the environment, and thus the environment will be polluted. So we do not want this to happen. So we isolate the well. And once we isolate it and we leave it, the well becomes an abandonment well. That's it. As for the appraisal well, it's the same thing. You know that the appraisal wells are used for determining it's used for determining how big the reservoir is and how much hydrocarbons does it contain. So once we found out that the reservoir is not big enough or it does not contain as much hydrocarbons as to be economically viable, in that case, this well will also be closed. It will be cemented, it will be isolated, and it will be left alone, which means it will be abandoned. Once the well is abandoned, the well becomes an abandonment well. The same thing goes for the production well. But for the production well, the well has to die first, and then we will make it abandonment. Like how? For example, the well is producing for so long, maybe for 10 years or for 20 years. It's producing means it's giving us the hydrocarbons. The hydrocarbons are being extracted from the well. But once the well has reached to a limit where it can no longer give us the hydrocarbons, it can no longer produce hydrocarbons, in that case it means that the well is dead. And what do we do with the dead wells? We isolate them. We close them so that the gases will not come to the surface into the environment, so that the environment will be safe. It's all for that. It's all because of the environment. So we put the cement into the well. It's the same procedure, and we isolate it from the environment, and we will leave it alone, which means we will abandon the well, and the well becomes an abandonment well or a dead well. You can call them the both. Alright then, so just to clarify the types of the drilling wells, I need you to take a look at these questions and answers. Well, you see, these questions and answers can lead us to the decision whether we should drill or not drill the production well into a reservoir. Which means we need these questions in order to be able to find out whether the reservoir deserves to be drilled or not. Well, the first question is, where is the reservoir? At this point, we're still looking for the reservoir. We do not know where the reservoir is located, so we're just going to locate it. And to locate the reservoir, we have to conduct the geological and geophysical surveys, such as the seismic surveys. We talked about this in the last lesson about explorations. Alright, so after the survey results, after performing the survey operations, the survey results showed that the reservoir is located at a particular place. So now we know where the reservoir is located. At this point, we come to our next question. Does the reservoir contain any oil and or gas? Well, we know where the reservoir is, but does it contain oil and or gas? Well, to answer this question, we're going to have to drill the exploration wells. And you already know that the exploration wells are used for determining whether the reservoir contains any hydrocarbon or not. So after drilling exploration, we'll find out whether the reservoir contains any hydrocarbon or not. If it does, then at that point we come to our next question, which is how much. Okay, the reservoir contains hydrocarbons, but how much? How much oil and or gas does the reservoir contain? To answer this question, we're going to have to drill the appraisal wells. And you know that the appraisal wells are used for determining the size or the volume of the reservoir and the initial hydrocarbons in place, the amount of the initial hydrocarbons in place. Well, if the results from the appraisal well are positive, which means that the reservoir is economically viable, the reservoir contains enough hydrocarbons as to be economically viable, then in that case the reservoir deserves to be drilled, which means we are sure with the decision that we should drill for the reservoir and extract the hydrocarbons from the reservoir. Okay, so I think it's enough for the first part, and I'll explain the second part on Wednesday. And the second part is going to be about the drilling methods like rotary drilling and cable tool drilling. Then we'll talk about the main components of the rotary drilling rig and their functions. It's going to be very beneficial. Until then, stay safe, guys.